Good morning, Bronx Middle School Math. Today we are going over lesson 4, which is going to complete how we use attributes to place shapes within the quadrilateral hierarchy. Now that's a tough word to say, quadrilateral hierarchy. Now that has to do with all the shapes that have 4 sides, and we use attributes to put them on that hierarchy. So let's begin by reviewing yesterday's exit ticket. So the first question is, choose a quadrilateral that can be classified in more than one way. Explain what the most precise name is for that shape based on the unique characteristics as well as how else it could be classified. So take 10 seconds and pause the video, come up with your answer, and we'll see what we get. Same thing for number 2. Explain why a square is the most specific shape on all of the quadrilateral hierarchy. Why can't any other shape always be classified a square? Pause the video, take 30 seconds, take a minute, however long you need to write down your answers, and we will get to the correct ones. Okay, now that you've unpaused the video, here's what we have for question 1. Now, remember, you can choose any quadrilateral that you wanted, but we just went with a rectangle. Now, a rectangle fits the rules for and could be called a quadrilateral because it has 4 sides. Remember, we start vague. 1, 2, 3, 4. Quadrilateral. And it has one pair of parallel sides right here, so it's a trapezoid. And, it has another pair of parallel lines, parallelogram. And 4 right angles, rectangle. So that is how we can use attributes to place a shape in the quadrilateral hierarchy. We start vague and start looking for attributes to get a very specific title. Let's go into question number 2. Explain why a square is the most specific of all the shapes on our quadrilateral hierarchy. Why can't any other shape always be classified as a square? So a square is the most specific shape because it has the most rules to follow. It must be a quadrilateral, 1, 2, 3, 4, quadrilateral. It must have at least one pair of parallel sides, trapezoid. It must have another one, so it must have 2 pairs of parallel lines. So it must be a parallelogram. And it must have 4 right angles, and opposite sides are congruent. So a rectangle. And then all 4 sides must be congruent, meaning all 4 sides must be the same length. That is what makes it a square, is having all 4 sides that are equal in size, equal in length, 4 right angles, 2 pairs of parallel lines, and 4 sides. So it's the most specific because it has the most rules to follow. Let's review the discourse from yesterday, lesson 3, to get the most salient and important points that we discussed. So pause the video and read this paragraph. Let's underline some of the most important parts. Now, my line isn't too pretty, but one of the most important parts of this slide is that a square is always classified as a rectangle, parallelogram, trapezoid, and quadrilateral. To be a square, it must meet the rules and expectations for rectangle, parallelogram, trapezoid, and quadrilateral. So you have to go through all these phases before you get to square. But remember, every square is a rectangle. Every square is a parallelogram. Every square is a trapezoid. Every square is a quadrilateral. But not every shape that's a trapezoid is also a square. Remember how we said yesterday that everyone from Texas is an American? But not all Americans are from Texas. It's the same thing here. All squares are trapezoids. But not every shape that's a trapezoid is a square. Pause the video and say that in your head until you can understand and put it in words that you can relate to and that you understand. So not every every rectangle is a trapezoid, but not every shape that's a trapezoid is a rectangle. So everyone from Texas is an American, but not every American is from Texas. This is a great photo of the quadrilateral hierarchy. You see how we start vague up here with the quadrilateral? Remember, the only rule it has to follow to be a quadrilateral is 4 sides. Then, when we move to trapezoid, it needs to have at least one pair of parallel lines. So we start off with a quadrilateral, must have at least 4 sides. Then we get more specific. Now, to be a trapezoid, you must have 4 sides and at least one pair of parallel sides. When we move to parallelogram, we get even more specific. Not only do you have to have 4 sides and at least one pair of parallel sides, you have to have 2 pairs of parallel sides to be a parallelogram. And the rules for rhombus and rectangle get even more specific, which we will get into now. But a quadrilateral that we haven't mentioned yet is a kite. So where would a kite go on this chart? Because remember, a kite, let me write down the definition. So the rules for a kite is that it must be a quadrilateral and it has 2 pairs of congruent lines that are adjacent. So look at this kite that I drew here on the right. You can see the blue lines are congruent. They are equal to each other and they are next to each other. They are not across from each other. And then the purple lines are also adjacent and they are next. They're adjacent and they are congruent. So that is what we mean by adjacent, next to. So where would this shape, the kite, go on this quadrilateral hierarchy? Because there are no parallel lines in this kite, so it can't be a trapezoid and it can't be a parallelogram. So where would it go on this hierarchy? Well, this picture here does a great job of laying it all out for us. So notice how the trapezoids and all the quadrilaterals with parallel lines are over here. And then the kite that doesn't have any parallel lines in this picture goes on this side of the line. It's still a quadrilateral. So pause this video and stare at this picture and make sure that we can understand why the kite is on its own. It's because look, no parallel lines. So it can't be a trapezoid, but it's still a quadrilateral because it has 4 sides. So today we are completing the quadrilateral hierarchy with a rhombus and kite. We're going to finish it off. So we are going to master rectangle, square, rhombus, and kite and how they play within the quadrilateral hierarchy. So let's go into some examples here. Or not examples, but listing the attributes of the kite and rhombus. So as we said before, the kite is a quadrilateral. It has 4 sides, but notice this kite right here has no parallel lines. This kite does have 2 pairs of congruent lines that are next to each other. So with a rectangle, 1, 2, 3, 4. The lines that are adjacent would be 4 and 3. So look at this. The adjacent lines are 4 and 3 because they are next to each other. But opposite lines are 1 and 3 because they are across from each other. So let's go to this kite and label the sides 1, 2, 3, 4. Now let's figure out, write down what are the adjacent sides and what are the opposite sides. So here we go. On this kite, the opposite sides are 2 and 4 and 1 and 3. And notice, 4 and 2 are not parallel to each other because eventually, if we continue this line and then continue 2, they would cross. So they are not parallel. But adjacent, next to, 4 and 3, they are next to each other. And they are the same length. Notice how they're both blue? Because they are the same length. So they are congruent. But notice 4 and 2 are not the same length. 4 and 2 are not congruent. So the lines that are congruent are adjacent to each other, not opposite. So a kite is a quadrilateral and has 2 pairs of adjacent lines which are congruent. A rhombus is a quadrilateral. It has 4 sides and it has 2 pairs of parallel and congruent lines. So it's a parallelogram. And all 4 sides are congruent. So all 4 sides are the same length. So 2 pairs of parallel lines. So 1 and 3 are parallel and 2 and 4 are parallel. 1 and 3 are congruent in length. They have the same length. And 2 and 4 are congruent in length. They have the same length. But not only are opposite sides congruent in length, but all 4 sides have the same length. So all 4 sides are congruent. So ask yourself, why is a rhombus always a trapezoid? Let's go back up to the quadrilateral hierarchy photo to see. So look, here's a rhombus. And we can see here that it's always going to be a parallelogram and it's always going to be a trapezoid and always be a quadrilateral. But why? Pause the video and write down why a rhombus will always be a trapezoid. We use the attributes of rhombus and kites to articulate and prove it is a trapezoid. Rhombuses have at least 2 sets of parallel lines, which is more than at least 1 set. And remember, the rule for a trapezoid is at least 1 set of parallel lines. This attribute allows us to know that rhombuses are in the trapezoid family. But why is a kite only sometimes a trapezoid? Well, it's possible for kites to have no parallel sides, which is not meeting the rule for at least 1 pair. Kites must have 2 pairs of congruent lines, meaning that kites must have 2 pairs of lines that are equal in length, and they are adjacent to each other. The rules and descriptions for kites does not mention parallel lines. So it's kind of like the rule for quadrilateral. It's very vague. The description for kite is vague. The only rule for kite is that it have 4 sides and 2 pairs of congruent lines that are adjacent. So 2 pairs of lines that are equal in length and next to each other. It doesn't say anything about parallel lines. So if a kite happens to have parallel lines, then it is in the trapezoid family. If a kite does not have parallel lines, then it's simply a kite. So let's go back up here and look at this photo. This kite right here is simply a kite because there are no parallel sides. A square takes the final attribute of both a rectangle and the rhombus at the same time. Notice how the square has both final attributes. So I color-coded the attributes. Purple is what all 3 shapes have. And then this blue one right here is what is special to the rectangle. And this red one here is what's special to the rhombus. Notice how the square has both the blue, and the red. So the attributes that the rectangle, square, and rhombus all share are that they're quadrilaterals. They all have two pairs of parallel and congruent sides. So they're all parallelograms. And that implies that they're also all trapezoids. Now, the rectangle has 4 right angles. We can see that here. And the rhombus has all 4 sides are congruent in length. So all 4 sides are equal. All 4 sides are the same size. So if you put the rectangle and rhombus, like if you took their last final attribute, the blue one and the red one, look, the square has those. The square has 4 right angles and all 4 sides are the same length. A square meets all the rules for a rhombus. A square also meets all the rules for a rectangle. The only difference between a square and a rectangle and rhombus is that a square has extra rules. It has extra rules to its own title. The square has more specific standards. So basically, it's just saying the square has more rules to follow. Okay, let's get some practice in. We're going to do the guess my rule. I'm going to show you shapes, and you're going to compare the shapes that follow the rule and the shapes that don't follow the rule, and you try to figure out what is the rule we are applying. Let's begin. So we see a rhombus and a square work, but a rectangle and parallelogram don't. So let's write out the characteristics that the rhombus and square have, and then we'll write out the characteristics that the rectangle and parallelogram have. Okay, so we wrote out all the families and attributes that the shapes that work and that don't work, what they belong in. So we can see that the rhombus and square, they're quadrilateral, they're trapezoids, they're parallelograms, and a common attribute between the rhombus and square is that all 4 sides are congruent. So all 4 sides are the same length. Check, 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 check. All 4 sides, same length. Now let's go over to what doesn't work. The rectangle and parallelogram. What do they have in common? Well, both the rectangle and parallelogram are quadrilaterals, trapezoids, and parallelograms, 2 pairs of parallel sides. Okay, so I'm seeing that what the square and rhombus have, that the rectangle and parallelogram don't, would be this. All 4 sides are congruent. Because look, the blue lines are 1 length, and then the red ones are longer. And same for the parallelogram. These are longer, the red ones are longer than the blue ones. So I'm going to say that the rule is all 4 sides are congruent. Let's see. There we go. Parallelogram with all congruent sides. Good job, y'all. Okay, let's go on to the next one to master our skill. What is our rule? We have a rhombus, square, rectangle, and parallelogram. They fit the rule. What does not? A kite and trapezoid. Okay. So let's write out the characteristics of all these shapes that work, what they have in common, and then we can write out the characteristics of these shapes that don't work. Okay, so the ones that do work, the rhombus, square, rectangle, and parallelogram, these shapes are all quadrilateral, they're all trapezoids, and they're all parallelograms, meaning they all have at least 2 pairs of parallel sides. Now, for what doesn't work, the kite and trapezoid don't have much in common. What they do have in common are that they're both quadrilateral, so they both have 4 sides. But as you can see, this trapezoid has 1 pair of parallel lines. The black lines, those are parallel. But the kite doesn't have any parallel lines. but they still have the fact that they're quadrilaterals in common. So I'm guessing, okay, the rule can't be quadrilateral because they're both quadrilaterals. Okay. And the rule can't be trapezoid because, look, this is a trapezoid. If the rule was that they had to be trapezoids, this shape would have been over here. So since it's not, I know that that can't be the rule. So the rule must be that it has to be a parallelogram because look, the kite and the trapezoid, these aren't parallelograms, but all of these are. So let's go check it out. There we go, a parallelogram with two sets of congruent sides. Checks out. Now we're going to have a little bit of a debate, true or false. Now you want to make sure that you can defend your reasoning with an example. Are there other shapes that fit into this category? What attributes are unique to this shape? Is the opposite of this statement true? How do you know? So this is going to be a lot of practice, and it's going to take, we want to make sure that we take the appropriate amount of time. So pause the video and give yourself time to do this independently before we go through it together. So I'm going to stop this video, and we are going to spend the next video going through these examples and getting in the right amount of practice. So to do the true or false, go to the next video. What we covered in this video was that there are levels of specificity. That's a tough word to say. I need to practice that before I make a video. But there are levels to the quadrilateral hierarchy, and it gets more specific the further down you go. Now, this picture on the left is pretty confusing, but I recommend that you pause the video and really think about it. Really try to understand this picture. So as you can see, the outer rim is quadrilaterals, and inside are trapezoids. So it's saying that all trapezoids are quadrilaterals. That is true. And inside the trapezoids, we are seeing the parallelogram shape. So it is saying that all parallelograms are trapezoids. And that is true. And so on and so forth. But if you notice here, the kite is kind of like it's floating in between some. Because remember, some kites can be trapezoids. Some kites can just be quadrilaterals. The kite is a very vague shape. And the same with the rhombus. It's floating in between rectangles and parallelograms. It can be vague sometimes too. But if you stick with the rules and the hierarchy, you are going to be safe. So these photos here have the same meaning. They're just displayed in a different way. So pause the video and figure out which photo helps you understand the quadrilateral hierarchy the most. This one or this one? I personally prefer this one. Although it doesn't have kites on there, we know that kites would be right here. But for me, this picture is easier to dissect and understand. Remember, there are levels of specificity. I'll work on that. While y'all go to the next video and do the true and false, I'll be working on how to pronounce that word. But there are levels of how specific shapes are in the quadrilateral hierarchy, but they all share four sides. Remember, everyone from Texas is an American, but not every American is from Texas. So every rectangle is a quadrilateral, but not every quadrilateral is a rectangle. So y'all go watch the video of the true and false, which will go into great detail and be great practice for y'all. Y'all have a great day.